Okay, so far we have been working on adding or subtracting rational expressions. And today, for homework, you're going to have a few more problems, a little harder, a little more complicated terms. But we're also going to work on going the other way. So we're going to work on taking a complete fraction and resolving it into its parts. So for example, let's take a look at this problem where I've got 5x minus 1 divided by x squared minus x minus 2. Well, I can go ahead and factor the denominator into x minus 2 times x plus 1. And now if I want to know what this would be with a constant, and it has to be a constant term, so meaning no variable, plus another constant over this second term from the denominator. So I want to get this guy right here into this format with these two separate fractions. In order to do that, I need to figure out what this a term and what this b term will be. And there's a pretty simple and kind of elegant process that we're going to use to do that. So first, I'm going to go ahead and I'm going to take this and this top part right here, and I'm going to rewrite. Actually, I'm not going to rewrite it. I'm going to go ahead and I'm going to multiply it, and I'm going to multiply it by this first term in the denominator. I'm going to multiply it by x minus 2. So I'm going to kind of scroll over. Oh, no, I'm not. Multiply that by x minus 2. Okay, when I do that and I have to do it to everything on both sides. Okay, so I have to do it to this guy as well as these guys, right? This x minus 2 right here is going to cancel from this x minus 2, and I'm going to be left with, on the left side, 5x minus 1 all over x plus 1 equals, well, this x minus 2 goes away, right? And so I'm just going to be left with equals a plus b times x minus 2 all over x plus 1. All right, now I want to solve for a. So I'm going to do something a little bit clever here. And I'm going to say, what does this turn out to be when x equals 2? So I'm going to plug x equals 2 into what I got right here, and I'm going to see what I get. Well, I get 5 times 2 minus 1 all over 2 plus 1 is just 3 equals a plus, well, if x is 2, this turns out to be 0, so this whole term goes away, right? So I'm left with a is equal to 5 times 2 is 10, minus 1 is 9, divided by 3. Look at that, a equals 3. Ta-da, I know what my a term is. Okay, now I'm just left with trying to find my b term. So I'm going to do the same thing, only now I'm going to multiply my fraction by x plus 1. So I'm running out of room here, so I'm just going to kind of show you up here in blue that now I'm multiplying this, instead of x minus 2, multiplying it by x plus 1. So down here, I'm going to write 5x minus 1 divided by x minus 2 equals a times x plus 1 divided by x minus 2 plus b, because the x plus 1 and the x plus 1 are going to cancel. So now I'm going to do something again a little clever, and I'm going to solve this for when x equals negative 1, right? And the reason I chose that is because I want to get rid of this term. Now I could just plug 3 in right here, but I don't want to do that. That's more work than I actually need to do. So I'm going to go ahead and solve this for when x equals negative 1, and I'm going to get 5 times negative 1 minus 1 all over negative 3 equals 0, right, plus b. So b is going to equal negative 6 divided by negative 3. b is going to equal 2. So then I can go ahead and I can plug back into my equation. I'm going to do it up here, which I know is weird. I'll kind of make a little space here. This program doesn't give me a lot of room to work in all the time. And I'm going to get that the partial fraction I want turns out to be 3 over x minus 2 plus 2 over x plus 1. And that is my final answer. All right, I think that went pretty well, but let's go ahead and try another one just in case you don't get it. For our next example, let's go ahead and try 4x plus 41 over x minus 2 times x plus 5. See, I was trying to be nice to you guys. I even went ahead and factored the denominator for you. Okay? All right, and we want to resolve this into partial fractions that look like a over x minus 2 plus b over x plus 5. So I'm going to go ahead and I'm going to multiply this entire equation first by x minus 2. And I'm going to get 4x plus 41 over x plus 5 equals a plus b times x minus 2 all over x plus 5. Then when I plug in x equals 2, right, because I want to make this guy here equal to 0 because he's still got all this fraction and all this rational expressions going on. I really want to solve for this a now. So I go ahead and plug in x equals 2, and I get 4 times 2 plus 41 all over 2 plus 5 equals a plus 0 because that x minus 2, 2 minus 2 is 0. So it turns out that a is going to equal 49 divided by 7, which is just 7. Okay, I've got my a. Now I want to get b. So I'm going to multiply this guy a second time. And this time I'm going to multiply it by x plus 5. And I'm going to get 4x plus 41 all over x minus 2 because this x plus 5 up here is canceled with this x plus 5 there, equals a, and I know what a is, so I could put it in, but I don't need to. A over x minus 2 plus, oh, I'm sorry, not plus. Let's see if I can erase that. Oh, goody, I could. A over x minus 2 times x plus 5, all plus just b, because the x plus 5 here cancels with this x plus 5. Then I go ahead and I'm going to solve for this equation when x equals negative 5. So I get negative 20 plus 41, I'm running out of room, all over negative 7 equals 0, right, because this term right here goes away, equals 0 plus b. So b then must equal 21 divided by negative 7, which is just negative 3. So then I can go ahead and make a little space up here. And the answer that I then want is going to be my a term, which is 7 over x minus 2 minus 3. Right, I put the minus, I don't need to put plus the negative, so I just put minus 3 over x plus 5. Okay, so pretty simple. I think there's maybe 3 or 4 problems in your homework like that tonight. And if you have any questions, we will answer those when you get back. All right, thanks a lot for watching.